create an array, if we wanted to have an array of length 3, we would do int brackets array equals new int 3. Does this look familiar to everyone? Are there any questions about this? About what it does, what it means? So this sets aside a space for 3 integers, right? So for example, if I were to do array 1 equals 10, where did I just put 10? Right? Okay, so now you're seeing in tic-tac-toe we have int grid equals new int 3, 3. So what this is it's a 2-dimensional array, right? Rather than being 3 long, it's 3 by 3. So you'll have right? Funny, it looks like a tic-tac-toe board. Yeah? Does everyone follow that? Because it's an array that has 3 in one direction and 3 in the other direction, right? And so, for example, if we wanted to put the number 1 right here, what would we say? Did I hear 0, 2? So it's 0, right? Okay. So you do the row first and then the column. It's just a thing you have to memorize. I obviously had to double check that. You can always test yourself by printing out things in your program. See how you're doing, right? 2, 0, right? Notice that you have to do 1 bracket for the first one and 1 bracket for the second one. You can't have like 2, 0 like that. Yeah? Because it's 2-dimensional. So that's how you would set one of the values in here. Are there any questions about this? So that's what you do for tic-tac-toe. I think it's relatively straightforward as long as you understand arrays, but it's a new code that we can teach.
Did you make it with more columns and more rows?
Yes. So you can make it have more columns and more rows by changing these numbers, right? So if I wanted it to have 4 rows, for example, right? And it would have the same number of columns, but that just gave it an additional row. Yeah, so you could make this whatever you want, right? This is implicitly, I guess, int 1, 3, but you wouldn't do that. It's just 1-dimensional, right? Yeah.
So what about 3-dimensional?
Yes, but I can't draw it on the board anymore. You could do that.
And then you would have more brackets. So
And then it would go in this direction.
right, but more like in brackets.
Yeah, totally. So then you would have something like 2, 0, 0, and then it would still be this one, right? If I did 2, 0, 1, it'd be like right here. Yes, exactly. You can have as many dimensions as you want, and then it becomes magic. Any other questions about this? These are good questions. If you haven't done lab 3 yet, do it before you do tic-tac-toe. Even though we've passed week 3, it'll be worthwhile. Try updating your provided code, and we can help you on that as well. So let's go on to today's class. which is loops, which is when the real fun starts. So I hope you guys are excited, even though you don't know what you're about to get into. Okay. Oops. So we've seen repeated code in this class already, such as in Lab 3, if you've done it, a report card where you print out all the grades for the different students. You end up essentially doing print student 0, print student 1, print student 2, up until I think there's 6 students. Rock, paper, scissors, you guys all had this like massive if block of if this scenario, if that scenario, if that scenario, and they're all very similar to each other. Even in cashier, we were kind of following this formula of we do the 10s and then the 5s and then the 1s, right? And functions have fixed some of that for us, right? We've already found ways to remove provided code by putting it into a function, such as with printing students, right? Where we need to print grades for all of these students. And if you had to calculate the letter grade in a separate piece of code for every student that you did it for, you would have been copying that code over and over again. So we pulled it into a function, and then you just say print student 1, print student 2. But this still doesn't really scale up if you have, say, 100 students. You're still going to be copying print students over and over, right? So loops are the solution to that, which is loops are a way to repeatedly run a piece of code over and over again, right? So functions allow you to portion out a piece of code and call it, but you still have to call it once every time you want to use it. Loops are a way to say, just do this over and over. And you can do it over and over in a variety of ways. You can repeat over a data set. So these are all my students. Please do this once for every student. You could do it a certain number of times. Say, I just want to do this thing 10 times, whatever it is. You can do it until some condition is met. So maybe you're looking for something, right? Think of like Google search, for example. What if you're searching until you find 10 results to show on the page, and then you just want to stop, we found our 10 results. So loops are a way to just keep doing that until whatever it is that you told it to do. The name loop, if it's not already intuitive, think of just, it's kind of cycling some portion of code. In your code, it literally like goes through the code and then jumps to the top and goes through the code and jumps to the top. So it's literally looping. And each execution before you jump to the top again, we call an iteration. So you might hear me say that word. 1 iteration, 2 iterations, 3 iterations. So the first type of loop that we're going to learn, there's a variety, right? So I just showed you there's all these different ways that you can iterate. So these are going to turn into different types of loops, and you write them differently in your code. So it's all one overarching category of this is code that repeats, but there will be technically different ways to write these different scenarios. Does this all make sense so far? Let's actually see one of them. So this is a for each loop is our first kind. And this is, we want to do something for each item in the data set. So for each student, we want to print that student. Or for each item in the tic-tac-toe board, we want to print it out. And it specifically goes over arrays because arrays are really the only thing that we have that represents many pieces of data. So a for each loop will loop over an array. So this is what a for each loop looks like. The keyword for, that's a Java keyword. It's a special word. You can't name your variables for, etc. It means we're entering a for each loop, or we're entering a for loop. For each loops are a subset of for loops. If this confuses you, ignore what I'm saying right now. Right? For loops are a type of loop, and for each loops are a type of for loop. And so we say for to indicate that this is a for loop. And then we say int number, read this as in all numbers. So the colon is another special Java symbol, and it's saying for thing in this. Do you have a technical complaint? Oh. Oh, well, yeah, okay. I'll get there. So for each number, in all numbers, do this thing, all right? So what this does is it goes over and over again, and it goes for the first one, 2, execute. Next one is 4, execute. Next one is 6, execute. At the end of the array, we're done. So it'll do this over and over again. And then we print. Huzzah. All right. So I'm going to break down the syntax of all of these things. I got a little ahead. Jeff told me to go ahead on the slides. But can everyone kind of see intuitively why this code would print those things? If you trust me that that means execute over the array. Okay, so now the breakdown of what each thing means. So this is the Java key symbols that you need in order to create the for each loop. So there's the keyword for that I was talking about. There's the parentheses, just like a function or an if statement has parentheses. The for loop has parentheses, and then it's got the curly braces, right? And the curly braces indicate we're going to loop over whatever code you put in between them. So just like you could put lots of lines of code in an if statement, you could put lots of lines of code in a function, you can put as many lines of code as you want in the middle of a loop. The parentheses indicate this is where we're going to say what we loop over. That's where you give the specification of how long do we loop, what are we looping for, etc. And then the colon is the special keyword, or not keyword, symbol, saying we're going to loop for each something in something, and you read it as in. So to the right of it, we have whatever array we're looping over. So that's the variable name of your array, whatever the array may be. It can be a string array, an integer array, a double array. And then to the left, you create a name for the element in the array that you're looping over right now, right? And the reason is, in order to do this line, next number is whatever, we need to have named whatever one we're at so far. Is everyone following what I'm saying? So this says, okay, we're going for 2 and then 4 and then 6. And each time that it loops, it takes the next item in whatever this says. So in this case, it's the array. And it sticks it into this variable so that we can refer to it. This is really, really similar to what functions do when you do the inputs, right? The inputs of a function are between parentheses, and you would say int, input whatever, input 1. And then when you call it, it sticks the number into input 1, and now we have a variable to refer to that. Well, you can think of these as kind of the inputs to your for loop, except with the for loop, it grabs each of the inputs one at a time when it executes. And so this has to match this. Can someone explain to me why this has to match this?
Because you're trying to indicate which numbers are the ones you have to put the output with.
Yeah. So it's because this number is pulled from here, right? So whatever you get from the array, that's the type of thing you got. So if this were an array of words instead of an array of numbers, this right here is going to get you a word rather than a number. It's going to get you the contents of the array. And so Java will give you an error if this and this don't match, because you're saying, hey, please loop over all these strings, and now give it to me as a number. And it's like, what? You just told me to loop over strings, right? So that's why this, or this type of thing, is always going to be the same as this type of thing, except this one's an array. And this is a single one that we got. Does that make sense? And then this is just the code. And you can do whatever you want with it, right? Of course, you should probably use number somewhere in the code, probably. because if we're going to do something over each element of an array, we probably want to use that element. But other than that, there's no rules. You can put whatever you want in the loop. Are there any questions about how the for each loop is formatted or why you would use it? Yeah.
Why do you have to put number after names?
So the reason you have to put number is that we have to name this variable in order to use it later on. And so number will refer to 2, and then it'll refer to 4, and then it'll refer to 6, right? But in this code right here, when we say next number is, what would you put right here if you didn't have a name, right? So the reason that we put that there is so that we have named the value that we're working with so that we can keep going and do stuff with it. Did that answer your question?
Yeah.
Are there any other questions? Okay. So let's try it out. Or first, I'll just show this one to you as an example. You don't need to write it down or anything. Print out all of the program's arguments. So this is something that is really useful for you as a first step in every single one of your labs and assignments, right? Usually the first thing you want to do is just print out what you got in and sanity check, like, okay, I got it, right? Has anyone done that with their program so far? Just printed out the input? No? Maybe?
Julie, you're just weird, I guess.
It's a really useful trick, right? Because suppose you're doing some calculation on it and the result is coming out wrong, right? Well, my first sanity check is, well, did I at least get the right input for it, right? So it's very useful to just, first step, print out the arguments. Except we don't know how to do that, or we didn't know how to do that yet when you have multiple arguments, right? If we only had one string argument, how would you print it out?
The one with the string.
What's that?
What, I don't know if this is right. Is it, if this is right, like playing a 1 for the string?
Almost, it would be a 0 because we start counting at 0,
Oh,
right? But yeah, right? So if you do args 0, maybe I can just type right into the slides here. Does this look familiar to everyone, the line that I just wrote? So if we only had one argument, we would do that, right? What if we had 2?
One instead of 2.
Yeah, actually it would be, whoops, my computer does crazy things. Okay. So it would be in addition to it because we'd want to print them both. Why does my computer do this? It jumps slides when I'm not touching anything. Okay. So if we had 2, we would do this, right? If we had 3, we would keep going with args 2, etc. Except what if we don't know how many args we have, right? What if we told someone to type a whole sentence and then we'll do something with that sentence? Well, that's going to be a whole bunch of words and we don't know how many of them there are, right? So the whole point of having this loop is, well, now we can just loop over all the args and it doesn't matter how many there are. We're going to do it once for every one of them. Does everyone understand the logic behind this, behind doing this? Okay. So the way we would do this is with a for each loop. So to kind of walk you through what this does, let me present again. This one's still on? Okay, I'll go to this one instead. So for each of the inputs in args, right? Now string input, that's a variable, and so I could have named that anything, right? I could have named that string happy times. In args, so we'll do it once for everything in args, system.out.print, input plus, comma space.
Okay, so if we were to run this in Cloud9 and I were to write, I am happy, what would the output of this program be? Two? Why?
Because it's 3 words, so you
Oh, so you're counting. Ah, so you're counting indices, but this doesn't actually use the indices. So one of the things that is beautiful about a for each loop is that you no longer have to index. You no longer have to do 0, 1, 2, 3, right? You just say, for input in args. It doesn't matter how many of them there are. It doesn't matter where they're indexed at. It's just going to do this for each of them. So that's not quite right. Does anyone else want to make a guess at what this would say? Maybe I will just open up Cloud9 and put it in.
Could it be like your input and then the number, your input plus the number of the input?
So it doesn't say anything about the number of inputs actually.
Oh,
So let me bring it up for you guys again here. Okay. Here's my code from this. And yes, you can all see. Okay. So first of all, there's a gimme. There's something that it prints out no matter what the input is. What determines whether something gets printed? What is the line of code that you put in to make something print?
system.
Good. System.out.print. So off the bat, no matter what the args are, line 3 prints your input is ... right? So I'm actually going to show you. I'm going to run this. Where's my run button? Ah, there it is, right as I refresh. I swear sometimes Cloud9 is intentionally messing with me. Okay. Whoops. Where's my error?
You're missing an open brace after main.
Thank you. Whew. There we go. So I ran it, I gave it no args, and it printed out your input is. Is that surprising to anyone? Does anyone have questions about that part? Okay, so when we have no arguments, we just have your input is. Okay, so now let's look at the next system.out.print. Notice I used print rather than print line. What does that mean? What's the difference? Did I teach you guys this? No. Okay. Print line prints it and then goes on to the next line. Print just prints it and then stays on that line. So you could call print over and over again and it would keep adding to that same line. That's the only difference. Okay, so we have system.out.print. Input plus comma space. Okay, so when we're thinking, what does this print out? We'll look right here, right? Okay, so now suppose I type in, I am happy. And I was asking, what is that going to print? So our for each loop is going to iterate. It's going to do one iteration for each thing in args. What are args right now? Like, what are the contents of args going to be? How many things does it have in it? Brian actually already said this earlier. How many things are in args? 3. It's 3 words, right? So args just reads things separated by spaces, right? If you were giving numbers into your program, I would type 2 space 6 space 4, something like that, right? If I'm giving it words, I type I space am space happy, and each of those words go into one of the elements of args, right? So what's arg 0? 1.
Happy. Exclamation.
And which args, or which of them includes the exclamation point? Args 2, right? The exclamation point is part of it. Good. Okay. So we know what args contains. Now this for each loop we just learned is going to go once for each element in the array. So it's going to iterate once, and the first time it runs through, what's input going to be? I. And then the next time it runs through, it's going to be am, and the next time it runs through, it's going to be happy, right? So it's going to go through once for each of these. So as a result, when we run it, we get I, comma, am, comma, happy, exclamation point, comma. Why is there a comma at the end?
Add a comma every time.
Exactly. Did everyone understand that? Because I added a comma for every element of the array, right? So I didn't do anything smart where, oh, let me only add them in between the middle ones. I just added it after every single one because that's what my loop told it to do. So it did I, comma, am, comma, happy, comma. Are there any questions about why this code does what it does? Does everyone understand this? Yeah.
I don't know.
No, you're good? You're like, yes, I understand? Okay, cool. That's awesome. Okay, so let's try it out. So I'm super sad that Yesenia's not here because I wrote this example for her. I hope one of you knows the names of the members of One Direction because I don't. So we're gonna try it out. So if you haven't already opened your Cloud9 workspace, let's do that. Let's do the 30-second create a new file. I just did what I tell you guys not to do, which is typing it from scratch. You should not follow my example and you should copy paste it in from somewhere. Okay, so my hello world is running. I'm going to give you all another 30 seconds to catch up. All right, so we want to print all the names of the members of One Direction. Does anyone know their names? Yes. Okay. What are their names?
Harry, Niall, Liam, Louis.
Harry. Niall spells it weird, right?
Yeah.
Like that. Okay. Liam. Louis.
Yeah. There's another one for you.
Okay. We're good.
We don't mention
We don't talk about him anymore. Okay, I'm so glad you knew it. Okay, so that's what we want to print out. Just put it in the comments for now. Maybe I'll capitalize their names at some point. Now, if we didn't know loops or anything right now, what could we do to print them out? Functions?
No, I'll use arrays.
Use arrays? How would you do it without a loop? There's actually a lot of ways to do this without a loop. One of them is this. Right? That's a way to print out their names. Now we're doing this as an exercise for learning loops. So imagine a scenario where maybe One Direction had a lot more members, or it were coming in from the program arguments rather than being written right into your code. So then you would need a loop, just like we had where we wanted to print out all of the program arguments. So we need to be a little bit creative here in imagining why we need the loop, because it's a very simple example to help you learn. But we're going to go with it and say we need a loop to print these. So the first thing we're going to do is make an array that has all their names so that we can loop over it. Actually, I shouldn't tell you this. So if we have an array that has all of their names, what type of things should that array hold? If you were watching me type, you might have seen me type it just now.
Strings.
Okay. What should I call my variable? Someone who hasn't chimed in yet. You can literally pick anything you want to name it. Did I hear some muttering from the back?
Name.
Names? Let's call it names since it has many names in it, right? Okay. So we're defining an array, so we do that by doing braces and then putting everything between commas, right? So if I do this, does that work? I'm messing with you guys. There's an error here. What is it?
Oh, you didn't put the quotation mark.
Yeah. All right.
If you just select the word and type quotes, it'll put quotes around it.
Wait a minute.
A lot of it already has them.
That's false.
Works for me.
Well, no, it doesn't work for me. Okay. What's
How can
that?
I put like brackets around each of them, like the curly with
These,
quotation marks
the quotation marks.
on each name.
Why did I put it on each name? So we could have had it all be one string that just has the whole thing, but then there's no need for a loop. It's just one string, right? So because this is a dummy scenario, we could have done that, right? But because I want us to learn how to use loops, we're going to imagine that there could be a variable number of members of One Direction, and we don't know how many things will be in this array. Maybe someone else joins them, and it gets brought in through the program arguments or something. So we don't know how many members they have. Okay, so now we're going to write our for each loop so that we can print each name in the band. All right, so what's the first thing I typed? Do you guys remember? 4. What's the next thing I type? Parentheses. Oh, you're great. String.
Names.
Names.
In.
In, colon.
Names.
So I heard all names, I heard names. That's right. Yeah, there's an error here. So on the right, so we have 4 string names
Oh,
in names.
So after string, should probably put another variable.
Yeah, so we need something other than names here because we need a name. This is confusing. We need a name for the variable that we give to each thing in names.
Well, we can just change names to something else, so it'll be less.
So a really common thing that programmers do in their code is they do for string name in names, right? Singular name and plural names are different things. And this one refers to the collective of all the names. This one refers to just a single name. If you find that confusing, you could name this all names. And maybe we would call this band member. I don't know. Let's go with this just because they're obviously different things. Again, I typed ahead of myself, but what comes next? Yeah. Okay, so now we're gonna loop over all the members of the band, and we're gonna do something for each of them, and what we're gonna do is we're gonna print it out. So how do I print? And what should I print here? Sure. And number. Oops, I typed. There we go. Thank you. And then, of course, the beloved semicolon. All right, let's run it.
Oh,
That's all.
yes, I would have been so happy.
I know. I'm disappointed that she's missing it. But it's okay. She'll follow along on the video later or something. So now we have all the members of One Direction printed out. And that's our for each loop. Are there any questions about this one? Feeling good that if I gave you an array and said, print out all the elements of the array, you could do that? So we're going to get into more interesting stuff now, where we're still going to go over all the elements of the array, but maybe we want to do something other than just print it out. Maybe we want to do some calculation. So my next example is, let's try and write code to print the sum of the numbers 2, 4, 6, 8, 10. Or if we want to be a more realistic scenario, the sum of the input numbers from the program, right, would be how this would actually get applied. Does everyone understand what we're solving and why? Okay, so we're going to print the sum of the numbers 2, 4, 6, 8, 10. Except we're going to use a loop, because in real life scenarios, they would be program args and we wouldn't know how many of them there are. Are you guys understanding why we're doing these dummy examples? Is it working? Okay. Because none of these examples are really realistic because they're simple. You don't need a loop to do it, right? But they're good for learning loops. And once you get longer, you definitely need loops for these things. So we're going to print the sum. Okay, so let's start. We're summing 2, 4, 6, 8, and 10. So can someone help me write my array? Maybe someone who hasn't chimed in yet. So first off, actually, well, we can still do it in one direction. That's fine. My program will still be one direction. But what are the contents of my array going to be? So we're going to sum 2, 4, 6, 8, and 10. And so let's just write an array that contains 2, 4, 6, 8, and 10. Does it make sense why we're doing that? So that we can loop over and add them? Okay. So who hasn't participated yet? Alex. How am I going to write my array to hold 2, 4, 6, 8, and 10? String. Numbers. Wait a minute, right? And of course, the beloved semicolon. All right, you look so nervous, but you just cranked that out. Are there any errors in this?
Do you need a 0?
Do I need a 0, like right here?
Yeah.
So that totally depends on the specification of our program, right? So in the slides, it left out 0. It just said 2, 4, 6, 8, 10. But also, when we're summing it, 0 won't actually affect the result, right? So it doesn't actually matter. It just depends on whatever we wanted to write. We can include it. Anything else?
For strings, do you need the?
So if we wanted to have strings, we'd need quotes around them. Except you can't sum strings, right? Yeah, we actually want these to be integers so that we can add them together. All right, is there anything else about this line? I think it's good. Let's move on. Okay, so now we want to gather the sum of all of the numbers. So what should I write next? Int sum. All right, fabulous. So our sum is currently 0, right? Do you guys see where Amy's going with this? Of why she set it to 0? Do you see?
Yeah.
Can you explain why?
I think she just asked if the first input was 0, and then she wants the first 2 inputs, then it would be 2. And then it would be 6, and then 12, but it just go on straight.
Ah, I see what you're thinking. Yeah, so we're writing this with a loop, right? So what we're actually going to do is we're going to go over each of the numbers and we're going to add them into our sum, right? So that by the time we reach the end, we've added up all the numbers. So when we start, we're still at 0. But as we move on, sum is going to get bigger. So if you're not following this yet, it'll make more sense once we start. Okay, so we're going to loop over the numbers here. So someone who hasn't volunteered yet, how do I do that? How about someone at the back right table? How should I loop over the numbers? You want to help them out?
4.
Or
Parentheses. Plus sum. Numbers. And semicolon.
what do you guys think?
Oh, then the curly braces.
Ah, and when we have curly braces, we get to leave out the semicolon, right? Okay. So now we have int sum in numbers. That means that each of these numbers is going to get assigned to sum. Is that what we want?
Wait, I'm confused. Like, if we put int sum equals 0, then why would we put like for all the numbers?
Yeah, that's a good thing to be confused about. What we have here doesn't really make sense. First we set sum to be 0, and then we set sum to be the numbers. So we're just kind of overwriting sum here. So let's change this to be something else. Let's call it just like next, right? It's the next element of the array, all right? Okay, so now we have our sum is 0 right now, and we're going to do something for each of the next elements of the array. So not in code, but in English, can someone tell me what are we going to do for each element of the array in order to get our running sum? So Amy, what did you have in mind? What do you think we should do for each number?
Well, I was thinking since it goes like 2, 4, 6, it goes by 2 each time. I like, I don't know how to like express how I was thinking that.
That's okay. So what we want to do is we want to add each of the next numbers to some, right? So what we're going to do conceptually here
Maybe it's the markers, not the eraser. Okay. So we have 0, 2, 4, 6, 8. These are all of our numbers, right? We want to add them together. Maybe let's suppose they go on for some amount of time, but we don't know how many numbers there are. So what we're going to do with our loop is we're going to start with our sum being at 0. And then we're going to add 2 to it. Or rather, we would add 0 to it. We would add the first number. We'd add 0 to it. So now, sum is equal to 0 still. Then we would add 2 to it. So sum is equal to 2. Then we would add 4 to it. But sum is equal to 6. And we're just going through, oops. Then we would add 6 to it. Is everyone following what I'm doing right now? I'm keeping a running total of all the ones we've seen so far. Then we would add 8 to it. Still going. And then dot, dot, dot. For however many items we come upon. And what's nice about this is we don't have to know how many of these there are, but we can still add them together by just keeping the sum of what we found so far. So at the end of this, our sum should be 30. But as we went through, our sum was 0, and then it was 2, and then it was 6, and then it was 12, and then it was 20, and then it was 30, and then we ran out of numbers, so we stopped. Does everyone follow the math that I did? So each of these is going to be an iteration of our loop. Here's one. Here's one. Here's one. Some goes from 2 to 6. Some goes from 6 to 12. Some goes from 12 to 20. 20 to 30. So when we have 6 elements in the array, the loop goes times for each element in the array. And if the array were longer, it would go longer. And some would keep totaling up. Does everyone understand the process of this, aside from how the code works, but just the process of keeping a running total of what we have so far? So this is especially important, for example, if we're running a piece of code that we don't know when it's going to end, but we still want a running total. Think of like, the number of people who have visited my website. People will have that number counting up at the bottom, right? So there are things that you want to just kind of have running.
Julie,
So yeah,
is there a way that like you instead of having to write all that down, since it's like adding 2 each time, is there a way to like just do it one time?
So what's nice about this is you're actually only doing it one time because you have a loop. So the loop itself is only gonna go 6 times, but your code would only exist once, right? And then it would just go around 6 times. But because it is only adding 2 more each time, you could do something, but remember, we didn't add 2 to sum each time, right? Sum didn't go 0, 2, 4, 6, 8. Sum went 0, 2, 6, 12, 20, 30. So it's a little bit tougher to keep track of.
What if you change that 6 to a 17? Now there's no pattern anymore.
Sure.
Then you definitely need a loop.
Yeah, just to ensure there's no confusion. We could still do this with like these numbers. numbers, right? Like the way this code works, it would sum the numbers in this array no matter what the contents of the array are. So for our example, I started with 2, 4, 6, 8. But once we finish writing our code, we should be able to change those array contents to anything, and it should still sum them. Okay, so what we're gonna do here is we're gonna take this next number and we add it to sum. Okay? So we're gonna have sum equals sum plus. Everyone read that code, does it make sense to you? We take sum, we add next to it, and then we put it back into sum. So we're incrementing sum by the next number. What's a shorthand way of writing this? Do you remember from week 1? Nice. So I'll just put it in the comments. That's a shorthand way of writing it. Okay, so then at the very end, we of course want to print out our sum, or else there was no point in doing the calculation. Run it. Come on, run button. You can do it. Yes. 30. It added them all up. Our code works. Now, what if I were to change this to be this? So the reason we wrote this loop, right? If all we wanted to do was add 0, 2, 4, 6, 8, 10, we didn't even need code to do that, right? We could have just added them. Or we could have written, you know, int sum equals 0 plus 2 plus 4 plus 6 plus 8 plus 10, right? But by doing it in this array, it means that we wrote one piece of code that does the addition. And now those numbers can be anything. Those numbers can be handed to us from another program. They can be given to us by the arguments. Are there any questions about this code? No? All right, let's take a bathroom break and come back.
I accidentally exited out the bottom of the
What?
I like exited out the bottom.
It's fine, just hit run again.
So I did that.
What?
When in doubt, nuclear solution. Close it and open it again. Oh, really? Yeah. Mine's so broken.
Yeah, I'll be back.
So while I have a captive audience here, if you guys aren't busy with something else, do you have any cool ideas that you want to do as your final project? because we're just trying to gather ideas at this point of what might be fun. If you know anything that you might want to build. We're going to try to have some talks throughout the year to kind of say, how does what you're doing relate to real world things? So I guess we'll try to seed you with some ideas. Somebody we work with is coming in to talk in a week or so to talk about what they work on and how this is relevant. But at any point, if you have any ideas for like, this would be a cool final project, email us or post on Piazza or tell us during class or something.
You're trying too hard. That's what.
Was it, in what way was it different? Like they just had a lot of different words in it?
They use I, like for int, they use like int something I.
Yep.
Oh, that might have just been their personal like variable choices because
I asked them and they said like, if you put I think it was comma like equals 5, then you would repeat that from 5 to 6.
that's a for loop.
Okay.
So
Are we
we're
talking
learning
about-
for each loops, but a for loop is a very similar kind of loop. You'd say for, but then you would say like I equals 0, I less than 5, I less than less, and that means do this like 5 times.
Okay.
So
that's
yeah,
what they were
we
doing.
learned that I guess in 2 weeks because we aren't doing anything Thanksgiving week. But it's the next week.
I'm gonna run out. Do you want to just advance this one?
Oh, yeah,
I'll be right back.
Sure. Okay, let's get started again. Okay, so while loops. So we learned, why am I not presenting? Tail times. Okay, sorry about that. While loops. So we learned for yes.
I just have a question. If you're ever like missing class, is this like on the hangout thing so you can like see what's happening in class?
Yeah, it is.
Okay.
Marissa will flip through the slides along with us, or in this case, Jeff is flipping along the slides, or in this case right now, I'm doing it because Jeff's not here, so that it goes along with what I'm saying. Yeah. Okay, so we learned for each loops. There's a bunch of different kinds of loops. Well, we're gonna learn 4 different kinds of loops. That's really all of them. So we've learned one. It's a for each loop. It goes over all the elements of an array. Okay, so the next type of loop that we're going to learn is a while loop. It does something until some condition is met. So this is the scenario of like loop until we have found 5 results to show on the search page. Or in cashier, loop until we don't have any money left, right? So you might say calculate the hundreds and the 50s and the 20s, or those aren't real denominations. I guess they are, but not that. Anyway, right? Until there's no money left, and then just stop, right? So that's an example. So you can read a while loop as, while this condition is true, do this thing. Or if you like to think pessimistically, you can say, or until this condition is false, do this. Stop when it's no longer true. So here's what a while loop looks like. So instead of for being our keyword is while. Again, same structure. We have our parentheses and then we have our braces. Do I have slides again for that? Or no? No. Okay. So this time I get to actually explain it all. Right? So it's got parentheses, and inside the parentheses is the condition that while this condition is true. So while whatever in here is true, braces, do whatever's between the braces. Very similar format, but the difference is for each goes over all the elements of an array. While just goes as long as this condition is still met, right? And what can go in here is the same set of things that can go in an if statement. It's anything that you can evaluate of this is true or not true. So in this case, we have while counter is less than 5, do this. And then when counter is no longer less than 5, it'll stop doing it. Okay. Yeah, so when it hits 5, it stops.
Oh.
So it doesn't execute when it's 5. It only goes as long as it's less than 5. I said I would do the slides and then I didn't. Yeah. Counter is just a variable. Yep. Yeah.
So could you use like if statements just as well instead of using model?
So the problem is you would need an unlimited number of if statements because you don't know how many times this is going to go, right? So unlike, well, I guess with the for each loop, you don't know how long the array is, right? In this case, you don't know how long we're going to go until we hit 5, and so that's the purpose of the while loop. So there are some scenarios where we can do if as long as it's a finite number of things that we would do. So rock, paper, scissors, blizzard, Spock, there's only so many different situations you can have, and we just go once through each of them. But in this case, we're going while counter is less than 5, but we don't know how long it's going to be less than 5. Although in this case, when we read the code, we can figure out how long it's going to be less than 5, right? So let's walk through what this code actually does. So it's going to start by initializing counter to 0. It's going to check, well, counter is less than 5. Yep, it's less than 5. We enter. We're going to print counter is 0. Counter plus plus. What does counter plus plus mean? Do you remember? Increase it by 1.
Yeah.
Yeah. So counter plus plus means increase counter by 1. It's a shorthand for counter equals counter plus 1. Okay, so now we have counter is 1. While counter is less than 5, do we enter? Yep, it's 1. System.output line, counter is 1. Counter plus plus.
2.
2. Do we enter?
Yes.
3.
Yes.
4.
Yes.
5.
No.
No. So at that point, we skip to the end. We carry on. We print counter finishes at, and what's this going to be? 5. right? Because 5 was the point at which it didn't enter the loop again. Cool. So that's what this prints. Are there any questions about why this does what it does?
Could you do less than or equal to?
Yeah. And if we did less than or equal to, what would change about the output?
It would go up to 5.
Yeah, so it would do counter is 5, counter finishes at 6. Because it would execute when we were at 5. It won't skip to the end until we're at 6. Good question. Any other questions about this? Okay. Whoops. Okay, so my example of this is, say we want a countdown, t minus 10, t minus 9, t minus 8, etc., until we take off, because our program is a rocket ship, right? So here's how the code would look for that. Whoops, I have an error in this code. I wonder if you guys can find it. So,
There's no code.
oh, that's one error. That's not even the error I saw. This is what happens when I write my examples 10 minutes before class. All right, that's one error. So let's talk through what this does. It starts at 10. While count is greater, strictly greater than 0. System.out.println t minus whatever our count is. And then at the end, we blast off. What? It's not, what's not going to change? Count's not going to change. So this is called an infinite loop. I didn't mean to be teaching you about it, but I messed up. We never change count, right? So what's going to happen is we're going to have greater than 0, t minus 10, t minus 10, t minus 10. Should I keep doing this? T minus 10. We're never going to blast on. Okay, so so that was my error, right? If that happens, maybe we should see what happens. Java should give you an error. It should say something like infinite loop. Does it though? Let's find out.
No.
No, it just runs forever.
I think it'll notice it if you write something that looks exactly like this.
Oh yeah, it sure enough, it goes forever. It's still printing t minus 10. All right, well, I'll spare it the misery. So if you ever see yourself doing something over and over and over and over again, and it doesn't appear to be stopping, maybe you should check whether you were actually changing the variable that makes it stop. Now it can't stop because it's stuck running forever. Okay.
Yeah, I'm a little confused. Like, why does it go back to t minus 10?
Because we never, oh, go ahead and who was going to answer? I heard something over here. Right.
Because count still equals 10 when it's happening to count.
So in the last example, we were incrementing. Let me show you. That skipped too far. We were incrementing counter each time, and that's what made it go up by doing counter plus plus. But in this case, we never change count, so it's always going to be 10. Does that make sense? Okay, so let me fix that. So it decrements it by 1. So now count's going to go down by 1 each time. So what's this going to print out? Yeah. So does it print t minus 0? No. Okay. What can someone suggest? What could we do instead of count greater than 0 and have the exact same behavior? We could have it be greater than or equal to what? 1. Right? Greater than or equal to 1 is the same as saying greater than 0 when we're talking about integers. Okay. So that's our blast off example. Allow me to return to presenting. So while loops are good for counting upward, counting downward, doing something over and over again where some variable is going up or down. So even if we're not counting up by 1 every time, maybe we're multiplying by 2 every time, or adding 2 every time, like with the 2, 4, 6, 8 example. While loops are useful for iterating over the indices of an array, right? So maybe we wanted to, rather than just printing out the contents of the array, we wanted to print index 0 contains Niall, and index 1 contains Harry, and index 2, right? If we wanted to actually say what the indices are, then we would need some numbers, and you could use a while loop for that. So you could do a while loop where you would start with maybe a variable called index. It starts at 0, and it goes until whatever the array's length is. It's also, while loops are most useful, like way more useful than anything else, if you don't know how long it's going to take to get something, right? So maybe we're, I don't know, using random numbers and trying to get to a certain condition by generating random numbers, right? And you don't know how many times it's going to take to get there. So you need a while loop to just keep going until you hit whatever you're looking for, no matter how long it takes. So here's a perfect example, right?
Go figure.
With user input, right? So while the user input is invalid in whatever way, we ask them for input again. So think of rock, paper, scissors, lizard, Spock, right? You ask the human for something between 0 and 5. And if they give you between 0 and 4, and if they give you 6, for example, you could just say invalid input and exit the program, right? But what you really want to do is say, no, try again, something between 0 and 4. And you want to just keep trying again until they get it right. Did we do that in the, yeah, we did that in the code, right? So did you guys try typing something invalid and see what happens? Did anyone try that? In rock, paper, scissors, lizard, Spock? Yeah, so it would say something like, that's invalid, please try again. And so you can just wait forever. Your program can wait for the person to put in something good, right? So that would be a while loop. So while the person's input is invalid, just keep asking them for it. Okay, so this time we're going to try a while loop. Now we could do this with a for each loop, right? We could do this without a loop at all, but we're going to try it with a while loop to print the numbers, the squares, from 0 squared to 10 squared. So let's go back to Cloud 9. Oh, I only have 10 minutes left in class. Okay, I'll walk you through it relatively quickly, rather than having you try to do it. So we're going to print the squares from 0 to 10. So we're going to start with our number being 0. And we're going to go until it's 10 and then leave. So we'll do while num is less than or equal to 10 because we want to include 10, right? We printed square. And what am I missing? One button. There you are. And there's all my squares. I just wrote that up really quickly because we're almost running out of time, but are there any questions about it since I went through it so fast? This code will be in the slides. Okay, so it starts with num at something, right? We go until we get whatever we want our last number to be, and then we increment it each time. This was easier than writing a for each loop, right? Because a for each loop, we would have had to write out in the array 0, 1, 2, 3, 4, right? This one we know we're doing something predictable. So similarly, when we had 0, 2, 4, 6, 8, because it's predictable, we could have used a while loop to do that and just gone up by 2 each time, except it gets complicated with the sign, which is why we didn't do that. All right, so there's our code to do that. So the next example, write a while loop to find the smallest value of x such that x squared is at least 2,000. So what we're really trying to do is find the square root of 2,000, but we would do this by searching upward until we find a number whose square is big enough, right? You would need a while loop for this because you don't know which one is going to have a square that's big enough. So you just have to keep searching upward until you find it. So we could start at 1, right, and then just keep going. Does that make sense? So I'm going to skip ahead and show the code because we're short on time. Although if you want to solve this on your own later, you can close your eyes and ears. So we'd start with our number at 0, and we'd loop while that number squared is less than 2,000. So you don't necessarily in your while condition just need to have while num is less than something, right? You could do some calculation. You could say while its square is less than something, or while that number doubled is less than something, or whatever you want to do with it. And in this case, we didn't even print something inside the loop, right? We only printed at the very end. And inside the loop, all we did was increment num. So the point of this was really just to keep going until we found the right number. That was the only point of our whole loop. Does everyone understand this example? Are there any questions about it? I'm going pretty fast because I'm trying to finish up. So stop me if I'm going too fast.
So basically, you just added the condition including the x value. It's like num.
Sorry, I didn't follow.
So the condition is set to like until x squared is equal to 2,000.
Exactly. Yeah. So you could read this as until the number squared is 2,000. Keep going. But or is at least 2,000.
So it should be equals.
So that's a really good question. So if we had until num squared is equal to 2,000, the problem is we could bypass it, right? Num only goes up by 1 every time, but squares go up much faster than that, right? The square numbers go 1, 4, 9. I won't keep going. 16. And so the problem is, if we have a particular number we're targeting, right? Well, what if the number before it, its square is 19 something, right? And then the number after it, its square is 22 something, because the squares are jumping upward. If you only had equals, it would never stop. It would pass it and keep going.
Stop at 2,000.
Because if you only had equals, it would never be equal. Does that make
So it's
sense?
literal.
What?
It's literally.
Literally equal. Yeah, exactly. So that's why we tend to use less than or equal or greater than or equal in our while loops, because if you have equal in a while loop, there's a chance that you'll bypass your condition. And then it'll never stop. It'll just keep going. Yeah, that was a really good question, because that's a commonly made error. Did everyone follow why equal would not work?
There's an example later.
Yeah, I know, but we're not there yet. I'm going to skip over this one for now. So you may have noticed there's a really common, oh, actually, that's not even, yeah, okay. So I already talked about this, actually. So we can also use a while loop to go over all of the elements of an array. A for each loop is a simpler way to do this. So the only reason we would want to do this is if we need the index, right? But we could do this by starting with the index at 0, repeating until it's array.length, which is how you get the length of the array, and then we would increment, right? So that's one way that you can use a while loop. So this is our slide dedicated to not accidentally creating infinite loops. Does anybody see an error on here? So we have int I is 0, while I is greater than or equal to 0, print I plus plus. Why won't we ever stop?
Because I or B less than 0.
Does everyone else see it? So our greater than or equal is in the wrong direction, and so it'll just keep going forever. Right? Because the stop condition is if you're ever less than 0, but we're never less than 0. So you have to be careful to check that these align. So if you're trying to be greater, or if you have a greater than or equal, you should be going down each time so that eventually you're not greater. If you have a less than or a less than or equal, you should be going up each time. So eventually you're not less. If you use equals, it's even riskier, like we were just talking about, because there's a chance that you'll bypass that condition. So we have while I is not equal to 0, print I, and then we subtract 2, right? So in this case, we're trying to stop when we hit 0, but by doing it this way, we have 5 is not equal to 0, so we print it. We go down to 3. 3 is not equal to 0, so we print it. We go down to 1. -1 is not equal to 0, so we print it, right? Go down to -3. -3 is not equal to 0, right? And we would just keep going and going. We never hit 0, and we're now stuck in an infinite loop again. It's the same scenario as if you had done equals with these squares, because there is no integer whose exact square is 2000. So we would have passed it and keep going. So it's generally safer to just use less than or equal, greater than or equal. And then the last common error is making sure just like the mistake that I had earlier, the variable in the condition is modified in the loop. So someone who hasn't chimed in a while, what's wrong with this one? I'll give you a hint. It says it on the slide. The variable in the condition isn't modified in the loop. What's the variable in the condition? Deja?
Wait, okay, you're asking what's wrong.
What's wrong with
Why
it?
is it wrong?
Yeah.
Is it the what's it called? After before the equal sign?
The less than, you mean? Nope. So the problem, anyone else want to try for it? The problem is we're doing while j is less than or equal to 6. So we have I is 5,
Julie.
j is 3. Yes, I do. But that wasn't what I was getting at. But you're totally right. Okay. So we have I is 5, j is 3. While j is less than or equal to 6, we print I. So what do we print? 5. Okay, we printed 5. I plus plus. So now I is 6. So I is 6 and j is 3. So while j is less than or equal to 6, is it? We print I. So we print 6. I plus plus, so now I is 7. All right, while j is less than or equal to 6, is it? We print 7. What's wrong here? Nothing's happening to j. So we incremented something, but we didn't increment the thing that mattered, right? J never changes. So you have to make sure that the one that's in the parentheses, which is determining how long the loop goes, gets changed somewhere. Oh, that's a wall of text. So the things to think about are, does my end condition work? Is it possible? Do I change the right variable? Does my less than or greater than match the plus plus or minus minus? Be really cautious about using equal equal. And if you're using an array, use a for each loop instead. They're a lot easier to use, right? While loops, you have to be really careful to get everything in the right place so that you don't end up going infinitely. For each loops are gonna stop, right? They stop when the array runs out. So they're easier to use in that sense. So we kind of flew through the end, but made it just at 8:30. So did anyone have questions about any of the stuff that I kind of rushed through? Are loops cool? I think they're cool. Okay, we got one. Did you have a question? You need to leave? Yeah, go ahead. That's fine. Time is up. So you guys are free to go. My final spiel. If you haven't taken the office hours survey, take it, or else I'm holding office hours when you can't come. Do lab 3 if you haven't done lab 3. Do lab 3 if you haven't done lab 3. Do lab 3, it's not too late. You have been forgiven and you can still do it. Okay. Also, no class next Thursday. Next Thursday is Thanksgiving.
Thank you.